Hey guys, it's me again. Um, Hopefully things are going okay. Today we're going to talk about section 9.6. This one is about translating conic sections. So far we've talked about parabolas, circles, ellipses, and hyperbolas, but the one thing that was consistent about all of them is we centered everything at 0, 0. So when we did parabolas, all the vertexes were at 0, 0. Centers of the circles are at 0, 0, so on and so on. Today, the only thing we're going to do, everything works exactly the same, except we're not going to start at 0, 0. You'll find a lot of this works similar to how you expect. We've talked this year about how, like when we did our sine curves, we knew, the 2 was the amplitude. We talked about, how the number here affected the period, but the number inside the parentheses, that was our phase shift, right and left, and then we had our vertical shift. Now, one difference between the trig graphs, like those, if you remember those, and what we're going to do today is those were solved for y, and our standard forms generally are not solved for y, so there'll be a small little tweak, but they work basically exactly the same. So what we're going to do first is, if you look at, these are our old equations. So parabolas, we had x squared equals 4py. That's for parabolas that go up and down, up or down. And then we had y squared equals 4px. That's for parabolas that are going right and left. That's not going to change. The only difference between what we're doing before and what we're doing now is we're going to center everything on a new point, and we're going to use the point HK as a consistent center point. Okay. Now, all of our equations stay in essence exactly the same. It's still going to be x squared equals 4py. The difference is we're now going to have a number inside with the x, so it's still going to be x squared. It's still going to be 4p, but now we're going to have a number inside with the x and the y. And what we do, the h coordinate goes with the x, the k will always go with the y. So we're just going to put minus h and minus k. So it's, instead of it being x squared equals 4py, it's still x squared equals 4py. The difference is now we have a new starting point. Okay, I'll come back to this screen in a second. So, for example, if we were to do this parabola right here. Now, this one's actually solved for the y. So, actually, let me go back to this and just show you the other equation. So, we had one that went with the x squared. The one that goes with the y squared is still going to be the same thing. It's still going to be y squared equals 4px. But again, we have the minus h and the minus k. Notice, the h is still with the x and the k is still with the y. Okay, so with our parabola equations, you'll notice they're still in essence the exact same thing. It's still x squared equals 4py, x squared equals 4py, y squared equals 4px. It's just we have that minus h and minus k. Okay, notice both of these are minus. Okay, in both equations. What that means is we're going to go in the opposite direction. So it kind of works like the phase shift, where we always go in the opposite direction. So what this means, if you see something like this, y minus 3 squared equals 8 times the quantity of x minus 2. Well, what that tells me is we're going to start at the point 2, 3, because the 2 goes with the x, the 3 goes with the y. Sorry, that's actually going to be a negative 3. So it's positive 2 because that's minus. Because that's plus 3, it'll be a negative 3. So the point 2, negative 3, that's just going to be our new starting point. From there, everything is exactly the same as before. The only difference is we're not starting at 0, 0. So before, we would take that coefficient and set it equal to 4p, just like we did before. So that means our p-value is 2. What that means is we're going to go a distance of 2 away from our starting point. Okay. Now, y is squared, which means the parabola must be going either right or left. We have a positive p-value, so we know we're going to go 2 to the right, and that's going to be our focus point. We're going to go 2 to the left, and this line is going to be our directrix line. Okay, and then this is just going to have our parabola going to the right. Okay, so everything is exactly the same. The only difference is we're not starting at 0, 0. The HK in this case actually becomes our vertex. So we're not going to be at 0, 0. Now, the easiest way to find our focus point is actually graphing it. We know we went 2 to the right, so we're actually going to be, our focus point is now going to be at 4, -3. And we can label the equation of our directrix, which again is a line. This happens to be a vertical line, so it's going to be x equals, it's actually the y-axis, or the equation x equals 0. So you'll notice parabolas are not that much different than what they were before. Again, the only difference is we're not starting at 0, 0. Okay? Now, back to these equations. So our parabola equations didn't change a whole lot. Our circle equation is not going to change a whole lot. It's still going to be x squared plus y squared equals r squared. The difference is we're going to have a number in with the x, and we're going to have a number inside with the y. So again, it's going to be minus h minus k. The point inside the parentheses is just going to be our center point, hk. So when we go to graph one of these, our equation might look something like this. X plus 1 squared plus y minus 3 squared equals 9. So that means the center of our circle is just going to be at the point -1, +3. It's always the opposite. That's plus, so that's minus. That's negative, so that's positive. So we just go -1, 1, 2, 3. And there's the center of our circle. We can still take the square root of that, so that's still our r squared, which means our r value is 3. And we're going to go 3 in all directions. We just go 3 from here. We're just not going 3 from 0 every which way. So we go 1, 2, 3 to the right, 1, 2, 3 up, 1, 2, 3 to the left, and 3 down. And we have a circle that looks something like that. When we do circles, the only two things that are important are the center point and the radius. Okay. Again, it's not changing a whole lot. It's still the same basic thing. It's just we're not starting at 0, 0 anymore. So just like this one, when we did the parabola, we still found our p-value the same way, where we just took that coefficient, set it equal to 4p, because that's the standard equation. We still went 2 to the right because y is what's squared. So we just didn't do it from 0, 0. Make sense? So back to our equations. So we have our parabolas, we have our circles, and now we got to talk about our hyperbolas. Our hyperbola equations, again, we need 2. Just like we need 2 for parabolas, we need 2 for hyperbolas, because x minus y and y minus x are not the same thing. Hyperbolas, if x is first, just like we talked the other day, that means we're going right and left. Y is squared, that means we go up and down. That's not changing. Remember, the parabolas are the weird ones, where if x is squared, that means it goes up or down. Y is squared, that means it goes right or left. Okay? Now, the standard equations are still going to be x squared minus y squared equals 1, and it's still going to be over a squared. It's still going to be over b squared, just like it was before. But again, we have a minus h and a minus k. So it's this equation becomes the same thing. We just have a minus h, we just have a minus k. Similarly, it's our other equation would still be y squared over a squared minus x squared over b squared equals 1. We just have a minus h in with the x, and we have a minus k in for the y. Our c squared equation does not change. It's still going to be c squared equals a squared plus b squared. That does not change regardless of which formula you're using. So when we do our hyperbole equations, all you have to remember, the common mistake is when the number that goes with the x, that has to go with the x coordinate, okay? Number under the x is still going to be our right and left direction. Similarly, our new equation for our ellipses is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. So just like the other equation, it just has the minus h and the minus k. We still have that secondary equation, c squared equals a squared, and it's still going to be minus. Remember, if this is plus, that's got to be minus. If it's minus in the standard equation, the c squared is going to be plus. Okay? So there are our new, I can almost get it on the screen. There are our new standard equations for all of our conic sections. Okay? Again, nothing is really changing as far as how we graph these. The only difference is we're not starting from 0, 0. Okay? So we've done a parabola. We've done a circle. So next we should do a ellipse. Okay? So again, standard equation. The number inside the parenthesis is what's going to give us our starting point or our center point. Now for an ellipse, this center point is not necessarily a key characteristics. Okay, so it's still going to be positive 2, that's plus 4, so it's going to be negative 4. All that point is for us of 2, negative 4, that's just our starting point. We're just going to move everything from there. Okay, the key characteristics are for ellipse, just like they were before, are our vertices, our co-vertices, and our foci. So we still got to label the same 3 important characteristics for ellipses. The number under the x is still going to tell us how far to go in the x direction. So x squared is that, or the a squared is 9. So we're going to go 3 to the right and 3 to the left. The the b squared under the y is 16. So that tells us to go up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. So we can draw our ellipse. Okay. And then 2 of those points are going to be our vertices and 2 of them are going to be our co-vertices. The bigger number matters here. So the bigger number gives us our vertices. So we went farther in the up and down direction, the y direction, than we did the right and left. So these 2 points are going to be our vertices. Okay. Now, the problem is we can't just say, plus and minus 4 anymore, because that point is not at 4. That point is at 2, 0. This point down here, that's also a vertex. That's at 2, and we went down 1, 2, 3, 4, and then 4 more to negative 8. So it's at 2, negative 8. That to me is the easiest way to label those points. Is really just tell me where they are. Another way to do it, the only shortcut way to do this, and this really comes in more when it's an ugly point, you can't take the square root really nicely, is another way you can write this is kind of think, how did we find those 2 points? We started at the point 2, negative 4. And then from there, we went up and down 4. So we can add and subtract 4 to the y coordinate. If we went right and left, we'd put it behind the x. So I'll show you that in the co-vertices, because the co-vertices are going to be these 2. again, I think the easiest way to label these 2 points, because they're nice points, so that's going to be -1, -4. And then the other one is going to be 2, that'd be 5, -4. So I think that's the easiest way to label those points. But there is a shortcut way, which again is kind of write your starting point, which was 2, -4. But then from that point, we added and subtracted 3 from the x coordinate. So we add and subtract 3. Okay. This means the same thing as just writing those 2. So it really doesn't matter if you want to write it this way, where you just label the 2 points, or you want to label it this way. That's just a shortcut way of doing it. Same thing here. So we have our co-vertices. These are just the 2 points. I think that's the easiest way. That's the shortcut. The shortcut might come into play actually more often when you do the focal points. And the reason that is we still got to find them, and we still use our c squared equals a squared, because that's plus, it's minus. It does matter in ellipses which one comes first, so we have to do the bigger number first, 16 minus 9. Okay, so the c squared is just going to be 7, which means c is going to be the square root of 7. We're still going to go in the major direction, or major axis direction. We went farther up and down than we did right and left, so the major axis will be going up and down. Square root of 7 is 2 point something, 2.5-ish. So we're going to go up and down about 2, a little bit more than 2. So there's our focal points. Now those are ugly points because we went up and down the square root of 7. So I highly recommend you do the shortcut version for those. So again, you just start with your center point, 2, -4, and then we wouldn't put it behind the x because we didn't go in the x direction. We went in the y direction, so we would add and subtract square root of 7 behind the y. So that's the easiest way to label those focal points. Okay. So with the first 3, it's really not a whole lot more work. It's just a little bit more work to find that center point. But again, everything is working exactly the same. We're just not starting at 0, 0 anymore. We're starting at some other point. Okay, let's try a hyperbola. Again, everything works exactly the same. The only difference is we're not starting at 0, 0. Our center point here, where we would start, would be 2, -1. Again, everything's opposite. So again, the difference is everything is just going to start from that point right there. Okay. X is squared is first, so that tells me it's going to go right and left. If y was squared, it would go up and down. Okay, the number under the x tells me to go right and left 4, so I'm going to go 1, 2, 3, 4. I'm going to go 1, 2, 3, 4. The number under the y, the 9, tells me to go up and down 3. Okay, and then just like before, I would connect those points with a rectangle. And again, the rectangle is not necessarily part of the drawing. It just simply helps us draw our 2 asymptotes. Okay, so the asymptotes, and you'll notice there's one ugly difference between the asymptotes now and what they were. The ugly difference is the b. There's no getting around it. When you start moving these things around, the b value is no longer 0, 0. So we're going to have to find those b's. In fact, we'll do that first. Okay. So we have to find the equations of these 2 different asymptotes, and there's definitely 2. We'll call this one asymptote 1. We'll call this one asymptote 2. When I go to find asymptote 1, well, it's still y equals mx plus b. We know how to find the equation of a line. We know the slope. The slope, we went up 3 over 4. So the slope is 3/4. The difference is we don't know the b value. Now, sometimes we can look at the graph. I'm going to predict this is, geez, if I drew this accurately, I bet it's about a half, somewhere in there. Sometimes we get lucky and we can, if we graph it accurately, we can just see the b value on the y as far as the y-intercept. Sometimes maybe the rectangle actually is one of the vertical sides of the rectangle is actually on the y-axis, so sometimes it's really easy to find the b's, but sometimes there's no getting around it. We have to have a point to plug in. The nice thing is we know both lines go through the center point, so we can just use that center point and plug in the y value, 3/4 times 2 plus b, and we can solve that for b. So that would be 6/4 or 3/2 plus b equal to -1. We subtract that 3/2. The -1 is the same as -2/2, so we get b is equal to -5/2, which means this equation, the first equation, is going to be y equals 3/4 x minus 5/2. I wish there was a better way to say that we could find the asymptotes easier, but there really isn't. That's just kind of the best way. Some people like to use point slope form if you're good at that, but I think y equals mx plus b is kind of the easiest way. But again, sorry, that's only one of them. We still have to find the other one. The nice thing is the slope is just -3/4. And we can use the exact same point. Okay, so the only difference is when I multiply that, we just get -3/2, which means now we're going to add that 3/2. So we got to do -2/2 plus 3/2, which we were right when we predicted it. That ends up being a half. So the equation of that one is y equals -3/4 x plus a half. So there are our two asymptotes. Yeah, it's a lot more work. There's just no getting around that part. And we still haven't even drawn our hyperbole yet. We haven't labeled our vertices, and we haven't labeled our focal points, which we still have to do. So we have our asymptote set. Sorry, it's more work. Now, back to this. We know it's x squared minus y squared. So again, if x is squared, we know it goes right and left. So we have our hyperbola that goes right and left. Remember, two of these points, those become our vertices, so we can label our vertices. And just like before, we can just count over and say that that's 1, 2, 3, 4, 5, 6, -1. And that looks like -2, -1. Or there is the shortcut way where we can start with the center point, which was 2, -1. And we added and subtracted 4 to the x coordinate. So it doesn't really matter which way you want to label those points. You can do it just by labeling the points, or you can do the plus and minus. Okay? But sorry, we still got to find the focal points. Yeah, hyperbolas are a lot of work. So we use our c-squared equation. Again, if the standard equation is minus, we know the c-squared equation is plus. It does not matter. It only matters which one's bigger in the ellipses. Hyperbolas, it makes absolutely no difference. If you put the smaller number first or the bigger number first, you're still going to add them. So I made this one a little bit nicer. So it's 25, which means c is going to be plus or minus 5, which means I'm just going to add or subtract 5. So it's a nice point now. So again, we can label those as nice points, where our foci become, that would be 7, -1 when we go out here, and that would be -3, -1. Or again, we can do the shortcut where we go 2, we added, subtracted 5, and then -1. Okay? Doesn't really matter which way we do it. Generally, we end up doing the focal points a lot of times like the shortcut because they become ugly points. I just made one that came out to be a little bit of a nicer point because I knew the rest of it, especially the asymptotes, were going to be pretty ugly. Okay, so that's how you graph it. This might be a good spot for you to hit pause, maybe come back tomorrow, try a few of these, and then come back to this point either the next day or, but we also have to do the ones where we find the equations as well. Okay, so let's try a circle with a radius of 6. We know what the standard equations are. So a circle, we know the standard equation is going to be x minus h squared plus y minus k squared equals r squared. Well, this one's easy. You just plug in the point. We know that's going to be x minus h, which becomes plus 5 squared. We put the y coordinate in for k, so it'd be y minus 1 squared. And then the r squared would just be 36, and you would be done. So the circles are easy. Circles never really are hard. They're not going to become hard. The last few SATs, I've seen one just like this on the SAT, where basically all you had to be able to do was pick out the center of the circle. And it really is super easy, okay? All right, let's try a ellipse one, okay? So if they give us something like this, an ellipse with vertices at -2, 1, -2, 9. So let's plot those. So -2, 1, and -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I like to put a little V next to those because I know those are going to be vertices. Focal points are at -2, 3, 1, 2, 3, and -2, 7, which would be right there. And I like to put a little F next to those just to remind myself that those are focus. And then we can draw a basic sketch. Okay. Now, think of the standard equation. We know it's going to be x squared over a squared plus y squared over b squared equals 1. So we know that part of the standard equation. The number that goes inside the parentheses has to be the coordinates of the center point. So we have to find that center point. You could use the midpoint formula if you really wanted to, or you could just kind of count, and we know the center point here is going to be -2, and it'd be 1, 2, 3, 4, 5. So we just put the +2 and the -5 inside the parentheses. So really it's just a matter of, can you find the focus or the center point? Okay, now the rest of it is more of a distance. So you have to find the distance from that center point. Think of how we would have graphed it. We would have started at the point 2, -5, and we would have went up and down a certain distance, right and left a certain distance. We don't know the right and left, so we can't find the a squared in this case yet. But we do know the up and down direction. Looks like we went up 1, 2, 3, 4, down 4. So because we went up and down 4 from the center point, we know this number has to be a 16. Okay? That all comes from the distance that we went up and down 4. Okay? We do know the up and down distance to the focus points as well. Looks like we went up and down 2. So that tells me the C value has to be 2, or C squared would be 4. Okay. Now, our equation, because that's plus, again, this has to be minus. It does absolutely matter. Do we put the 16 in for a squared or b squared? Well, because they called them vertices right at the beginning, that's one of the easiest tells. That tells us that it has to be the bigger number. So that has to tell me that it's 16 goes in for a squared, and we can solve that for b squared. So we just subtract. we get negative 12 equals negative b squared. So that means b squared equals 12. And I can put that number right underneath the x. And we have our answer. It all hinges on that center point. So you have to find the center point first. Okay. So that circle one we did, that was pretty easy because they gave us the center point. Okay. So let's try a parabola. Well, a parabola, remember the vertex ends up being that center point. So that 3, -1 is going to come into play here. So we don't want to start writing the equation yet because while we know it's going to be something squared equals a 4p and then something here, we don't even know if it's x or y yet because we don't know direction of this parabola. So we really want to start with a sketch. 1, 2, 3, -1. That's a vertex. Focus point is at 3, 2. So that tells me we have a parabola that's going up. Now, because it's a parabola going up, we know parabolas that go up or down, it's x squared equals 4py. So the fact that it's going up gives us that. Again, the center point, or in this case, the vertex, becomes our center point. That goes in for our h and k. Remember, they're always opposite. That's positive, so that becomes minus. That's negative, so that becomes plus. So we just have to find the 4p. Remember, the standard equation, x minus h squared equals 4p y minus h. So we have the h and the k. We just don't have that 4p number. But we can look at the distance between those. A lot of this hinges on the distance. We can see the distance here is 3. So our p-value has to be 3 because that distance is 3 between the focus point and the vertex, which means we plug it in for p here, and we end up with a 12 after we multiply by 4. So there's your answer. Okay. These a lot hinge on the distance from the center point, just like we did with that ellipse. The distance from the center, that's what gave us our a squared or b squared or even our c squared, because it's the distance to that focus point. Okay, so let's try a hyperbola. Okay, same idea. Well, with hyperbola, again, we right away, we don't even know if it's going to be x squared minus y squared or y squared minus x squared. We know it's going to be minus. We just don't know if it's up, down, right, or left. So a lot of it hinges on the sketch. So we start with a sketch. And I highly recommend using graph paper for these because it's just easier to count once you've got to find that center point. So 1, 2, 3, 4, 5. Lost track. 1, 2, 3, 4, 5, 6, 7, 3. 1, 2, 3. -1, 3. Those are going to be vertices. And again, I like to put a little v next to those. We have a foci at -9, 3, so it's a couple more that way, and 1, 3 going that way. So those are our focus points. So again, we have some sort of a hyperbola going right and left. Well, the fact that we're going right and left, that tells me a lot about the equation. That tells me it has to be x squared minus y squared. Okay. Now, what goes inside those parentheses? Well, again, it's that center point. So we have to find that center point between those 2 points. Again, if you wanted to use the midpoint formula, you could. I think it's just as easy. 1, 2, 3, 4, 5, 6. So 3 right in the middle. And then we find the coordinate of that, which is 1, 2, 3, -4, 3. So you just got to find the coordinates of that center point. Okay, so again, goes in here for h and k. It's always the opposite. That becomes +4 and -3. Now think about what that rectangle would have looked like. From here, we start there. We go right and left 3. We draw that rectangle, looks something like this. We do know how far right and left we went. We went 3 right and left. We could tell that just from the graph. That means the number under the x has to be a 9. But we don't know the up and down direction, so we have to find that. Again, we can use our c squared equals a squared plus b squared equation. The 9 is going to go in for a squared or b squared. It really doesn't matter if we put it in for a squared or we put it in for b squared. The c is going to come from the distance traveled to the foci, which is 1, 2, 3, 4, 5. So we're going 5 to the right, 5 to the left. That's the distance to our focus points, which means our c squared has to be 25. We subtract, a squared equals 16. There's our b squared, and we have our answer, okay? So again, a lot of it hinges on just the distance from that center point, but you have to find that center point, okay? So we've talked about graphing these equations. We've talked about finding the equations. One thing that we haven't talked about in a while is the idea of the axis of symmetry. Now, with an axis of symmetry, a parabola, all parabolas have one line of symmetry. Whether it's going up or down, we can have one line of symmetry going this way, or if it's a right or a left one, we might have a horizontal line, okay? But you'll notice those axis of symmetries have to go through that vertex. So let's go back to our parabola. If I can find which piece of paper that I wrote that on, okay? So let's take this parabola for example. Now, the parabola here, we have the center point was 2, -3. So if we look at an axis of symmetry, that means this axis of symmetry has to go right through that vertex. That's a horizontal line, and it's down at -3. So that's going to be the axis of symmetry would just be the one line, which is y equals -3. And you're done. Okay? If you had a parabola that was going up. So for example, I'll make one up here. If I had one that looked like, or up or down, let's say x minus 4 squared equals 16, y plus 2. That would mean my vertex would have to be at the point 4, -2. So I'll just draw a quick sketch. 1, 2, 3, 4, -2. Now, yes, I would go 4p equals 16. My p-value would be 4. X is squared, which means, and my p is positive, which means I would go up 4 from there. That would be my vertex or my focus point. Go down 4. There's my directrix line. I'd have some sort of parabola going up. But again, if I was only worried about axis of symmetry, I can see my axis of symmetry would be a vertical line that passes right through there. And again, that's a vertical line. All vertical lines have to be an equation x equals something, and that's at x equals 4. So the answer would be x equals 4. Make sense? Fairly easy. It's always the one that's squared. Now, so if a parabola has one line of symmetry, a circle, no matter what, would have an infinite number of lines of symmetry. But the difference is every single one of those lines of symmetry would go through the center point. So if I had to do a line of symmetry or axis of symmetry for, say, this circle that we did earlier, my center point was at -1, 3. My axes of symmetry would actually be any line that passes through the point -1, 3. You can't just say it's an infinite number of lines of symmetry. You actually would have to say it's any line that passes through that particular point. Okay? Make sense? You want to say goodnight? Mary, my daughter, wants to kiss goodnight. Hi, everybody. Good night. Say hi.
Night.
All right. Good night.
I want you upstairs, so get
I will come up in just a minute. Okay. Sorry. Ellipses. An ellipse would have two lines of symmetry. It would have one that goes up and down. It would have one that would go horizontal. Okay? But both of those lines would go right through that center point. So if we look at the ellipse that we did earlier, okay? The center point was 2, -4, okay? We would have one axis of symmetry that went right through there. And that axis of symmetry would be a horizontal line. So all horizontal lines are x equals something. Well, it's going to be x equals, all horizontal lines are y equals something. So that would be y equals -4. And that would have a vertical line right there. All vertical lines are x equals something, and it would be x equals 2. You can pretty much see the axis of symmetries right from whatever squared, okay? They really are very simple to find. For a hyperbola is going to have two lines of symmetry. One horizontal, just like an ellipse, one vertical. And again, you can see it right from the center point. So if I had to find the axis of symmetries of this hyperbola right here, center points at -2, 1 came right from those parentheses. The axis of symmetries are going to be horizontal line going right through there at y equals -1. And the vertical line would go right down the center at x equals 2. Axis of symmetries are super, super easy. There's not a whole lot to them. You can see the axis of symmetries right from whatever's squared. If it says x minus 2 squared, you're going to have x equals 2, the line, as an axis of symmetry. Y plus 1 squared. The only ones that are different, parabolas only have one. It's the one that's squared. And then circles have an infinite, but you would actually just write it has an infinite number of lines, or you do write it's any line that passes through the point, whatever the center point is. Okay? All right. Again, you may want to kind of stop here. This might be a good stopping point, but there is one more thing I have to show you. And that is how to take a equation that's not in standard form and put it in standard form. But before we get there, we have to be able to decide, what are we even looking at here? Is this a parabola, circle, ellipse, or a hyperbola? Now, there is a formal way of doing this with discriminants, but don't even worry about that. It's super easy. If you know what the standard equations are, then you can tell right from looking at just the squared coefficients. This 128 here, 6x squared minus 2y squared. Well, the only one that's x squared minus y squared, that is a hyperbola. So we put that's a hyperbola. 29, we can look just right here, x squared plus y squared. Well, they're both squared, it's plus, and these two numbers are the same. That is a circle. This one, only the y is squared. Well, only parabolas have lines that are squared. This is x squared plus y squared, and the coefficients are different. Well, that has to be an ellipse. You don't even have to look at the rest of it. This is x squared plus y squared. The coefficients are different. That's an ellipse. This one is only x squared. That's a parabola. This one's x squared plus y squared. And they're the same. That's a circle. This is x squared minus y squared. That's a hyperbola. So it's really easy to tell what you're looking at just by looking at the squared coefficients. Okay, if you know the standard equation, it's pretty simple. Okay, so if you had to put one into standard form. So we look at this and right away we know it's a circle. So we know the goal here. The goal is going to need to get it to look something like x minus h squared plus y minus k squared equals r squared. We know that's the goal. So we have to make this look like that. So here's how we do this. Step one, you regroup. So you take and you put the x squared and the 16x together. You put the y squared and the 8y together. This extra constant, get that out of your way. Throw it to the other side, okay? And now we do what's completing the square. You remember how to complete the square back from Algebra 2. We complete the square. Remember, we take half of that number, which would be 8. 8 squared is 64. So we add 64 to that side. But if I add 64 to the left side, I have to add 64 to the right side. We do it here as well. We take half that number, which is 4. 4 squared is 16. Okay? So we're completing the square. But if I add 16 here, I have to also add 16 to the right side. Again, it's take half that number, square it. So half of 16 is 8. 8 squared is 64. Now, once you get it to here, the right side here is pretty easy to figure out that that's 64. Now, we can factor this. This will factor nicely. There's two numbers that multiply to 64 and add up to 16. Well, those are 8 and 8, which means you get x plus 8 quantity squared. Plus, and now we factor this. Two numbers that multiply to 16 and add up to 8, negative 8 would be negative 4 and negative 4. So now we have it in standard form, which means center point is at, if I had to graph it, negative 8, 4. My radius is the square root of 64, or 8, and I could go from there. But it's completing the square. The one thing that you have to do, though, is if the x squared or the y squared have a coefficient that's not 1, we have to pull that out. I'll show you what that looks like. So let's say we have something that looks like this. Okay. Now, right away, we know it's an ellipse. So we know our goal. It's an ellipse because it's plus, it's x squared, y squared, and they're different. So we know our goal is to look something like this. Okay. All right. It looks like it's pretty daunting of getting there, but it's actually fairly simple. Step one, you regroup, just like we did before. Okay. So we have that 9x squared. We bring the other x over with it, so that's 36x. We have the 4y squared. We bring the 24y over with that. This 36, we just get it out of our way. We throw it to the other side. Okay. Now, one different step. Because this 9 and the 4 are there, we have to pull those out. Notice there's no number inside the parentheses other than 1 with that x and y. So we got to pull that 9 out of there. But you just factor it out just like you would before. And we have x squared minus 4x. And I would leave a little gap here. Plus 4, because we're going to pull that 4 out just like we did over there. So we pull it out of the y squared. We also pull it out of the 24, which would be 6y. Okay, so all we did, get those 4 and 9 out of our way. Now we complete the square just like we did before. Half of that number is negative 2. Negative 2 squared is 4. Now, if I add 4 here, I have to add the equivalent over here. The difference now is this 4. If I were to distribute that 9 in there, that 4 is not really a 4. It's really a 36. Because if I add a 4 on the inside, I have to multiply it by that number before I figure out what to add to this side. Same thing here. Take half that number is -3. -3 squared is 9. But I'm not, if I add 9 here, I have to add the equivalent. But that's not really a 9. If I distribute that, that's another 36. Okay? Notice I'm picking some nice numbers here. Now, right side, very simple to do the arithmetic. Now we factor. We have that 9 out in front. This will factor. Two numbers that multiply to 4, add up to -4 are -2 and -2. So we get 9 times the quantity of x minus 2 squared. Plus, we got that 4 out in front. That will factor into y minus 3 squared. And we're almost done. The difference is we got to get that to be a 1. So all we have to do is divide by 36 and reduce that fraction. So that becomes x minus 2 squared. 9 over 36 reduces to 1/4. Plus we have a y over the 4 over 36 reduces to 1/9. So all we have left is that y minus 3. And that equals 1. So we can get it into standard form like that. Just like circles, the only difference is we had to pull out the coefficients. And a common mistake, people forget that if I add 4 on the inside, I have to add the equivalent on the other side after I would distribute if I did. Okay? All right, let's try a hyperbola. Hyperbola is just like the ellipse. So we regroup. So we have the 9y squared. We know it's a hyperbola again because it's x squared minus y squared. We bring the 54y over with it. We bring the -x squared over there. We bring that 8x next to it. And we get that 56 out of the way. So just like before, don't like that 9 there. So I'm going to pull that 9 out of there, out of both of those two terms, which gives me y squared minus 6y. I also don't want that negative, so I want to pull the negative out, which gives me x squared minus 8x. Okay, so I got to pull those coefficients. I want those to be positive ones. Now we complete the square again. Half that number, -3. -3 squared is 9. Got to add the equivalent, which would be 81, because I have to multiply there. Here, half that number, 4. 4 squared is 16. I have to add the equivalent, so when I distribute, that would actually be a -16. So I'm going to subtract 16 to that side. Now, when I factor, I end up with 9 times two numbers that multiply to 9, add up to -3 or -6 would be -3 squared minus, this factors into just x minus 4 squared equals, oh, let's see, I'll cheat and use a calculator, which would be, come on, turn on. You can do it there, calculator. Let's see. We got a positive 81. We have a negative 56. And we have a negative 16, which ends up giving us a 9. Okay. Again, because we want it in standard form, this number can't be a 9. So, oh, my computer's starting to freeze. This number can't be a 9, so I divide everything by 9. So I end up with y minus 3 squared over 1. If you really want to write it, you don't have to. Minus x minus 4 squared over 9 equals 1. So now we have it in standard form. Okay. One more. Let's try a parabola. Now, one difference between parabolas and everything else. Standard form. If you think what standard form for a parabola, this one has y squared. So my standard form is y minus h squared equals 4p x minus k. Our goal is to make it look like this. Okay. Notice the y squareds are on one side, the x's are on the other. So actually the first step with a parabola is to do just that. We have y squared, we leave the 14y with it. We throw everything else to the other side. Negative 16x, and a negative 33. Get everything on the other side. Now, just like before, we're going to complete that square. So, that's missing a y there. Half that number is 7. 7 squared is 49. So, if I add 49 to that side, I have to add 49 to that side. This will factor into y plus 7 squared. And two numbers that multiply to 49, add up to 14. Over here, we have negative 16x plus 16. Now we're almost there. The only difference is we got to pull this 4p out of there. We want that to be a 1. So we want this x to have a coefficient of 1, which means I just have to pull that negative 16 out. And then I'd be left with x, and that'd be a minus 1. So now I have it in standard form. So parabolas are a little bit easier because you only have to complete the square one time. Okay. I know this was a long video, but do it over the course. Hopefully you did this over the course of the day. I know you can pause, rewind, things like that. So I went through it all in one fell swoop. This is not something I would have done in one day in class. This would have taken me at least 2 to 3 days to go through all of this. Give it a try. Go through some of the problems in the book and let me know if you have any questions. All right? Have a good night, guys.